So before we start lesson 2-4, we're just going to do a quick review on proportions and percents. And I think most of you will remember this, but it's good just to get a little quick review on it. I'm not even going to do a left column with this. We're just going to talk about a couple of the ways to set these up. Example 1 asks you to find 38% of 320. So a lot of you know that setting this up as an expression that you're just going to find, you would actually convert your percent to a decimal. You'd have 0.38. Remember, you move it back 2 places. So if it was 5% or 7%, you would need to move it back 2 places and have a 0 right here. Of means multiplication, and then 320. And you would multiply 0.38 times 320, and what you end up with is 121.6. But there's another way that you can set this up, and I'm sure you all remember this also, but I just wanted to give you a little refresher. That is over of equals percent over 100. So then you're looking for 2 of these 3 missing things to fill in. Notice we have 38%. Because it's 38 over 100, you don't convert it to a decimal like you would here. It is 38 hundredths, which that is 38 hundredths. So you're already setting that up that way. It's kind of avoiding the decimal. So you put in 38 where percent is, and then you look at if they're giving you the of or the is. In this case, they gave us the of, so you would fill it out. Is your variable. You don't know what that is. But 320 is your of. 38 was your percent over 100. And then as we're going to talk about in our actual lesson, this is a proportion. It's equal here. Different than multiplying 2 fractions. Equal means you can cross multiply. So 100 times x is 100x. 320 times 38 equals 12,160. And then you would solve for x by dividing by 100. And the really nice thing here on this particular one is that you know when you divide by 100, all you're doing is moving your decimal place back 2 places. So you're actually going to just think about your decimal being here, move it back 2. You end up with 121.6. Notice it's the same here. So that's just a quick review of finding percents with that formula that you probably learned. When you're looking at it in terms of a word problem, it's not always going to work with is over of equals percent over 100. Sometimes you need to think about it, I'm going to just put in real life, as part over whole equals percent over 100. So that's the other way to think about these. Whatever the whole possible amount is should be directly across from the 100, which is the whole possible amount in percentage points. Part, percent across from each other. And if you always set those up that way and you figure out what we're talking about here, then you should be able to set them up correctly every time. Now we're going to move on to lesson 2-4, which is going to include more of the cross-multiplying idea. Lesson 2-4, we're going to talk about proportions. We're actually going to skip right to example 4 because we want to focus mainly on proportions and not conversions. So first 3 examples we aren't going to look at right now. We'll talk about those at the end of the year. We'll go back to them. I'm just going to go ahead and start with the example, and then we'll go right on the left again. So I'm starting with example 4 just so that if you ever want to go match it to the example in the book, you can. In example 4, hopefully most of you remember what a proportion is from last year, is t over 9 equals 5 over 6. And what I've noticed this year is I've heard a lot of students already talking about cross-multiplying. When you are multiplying 2 fractions, that's different. That's a multiplication sign right here. When you're multiplying 2 fractions, You can simplify, you can cross-simplify if something divides into both numbers, but you do not cross-multiply. You multiply across if it was a multiplication here. So I think what happened is some of you confuse that with the rule for proportions. And the rule for proportions is the one where we talk about cross-multiplying. Very quickly, I want to show you why cross-multiplying works. If you think about what we talked about when we were solving equations originally, if I wanted this t to be alone, what would I do to both sides of my equation? I'd multiply by 9, right? Because t is being divided by 9. Well, if I multiply by 9, notice over here I'm going to end up with 9 over 1, and it's going to be times. If I had a 9 right there, it would end up multiplying to 5, wouldn't it? If I wanted 6 to move to the other side, I would end up multiplying both sides by 6. 6 over 1, I'd end up multiplying 6 to t. So that's why with proportions, when we see this equals sign, we know we can cross multiply, because you're basically taking the shortcut of multiplying the denominator to the other side on each of them. So, cross multiply. We have t over 9, I'm going to write it again, equals 5 over 6. And here's what it should look like. It should be a giant multiplication. So I have 6t equals, you always bring that equals sign down. 6t equals, and then you have 9 times 5, which is 45. So does everyone see how that can work there? Now I'm just solving for t. So I divide by 6 and I divide by 6. And I end up with t equals 45 over 6. And if I wanted to simplify that, I'd think about a number that I know goes into both. And I know 3 goes into 45 15 times. 3 goes into 6 twice. You can show your answer this way, or you can show it as a decimal. But I really don't mind if you leave it like that, as long as it's simplified. What I don't want you to do is leave it like that. You always need to simplify those. So over on the left, let's go ahead and write some stuff about that. First of all, you need to know what a proportion is. A proportion is two fractions set equal to each other. They don't have anything else with them. There's not a +2 over here or +5 or anything like that. If it was something like that, you'd have to handle this completely different. Proportion is two fractions set equal to each other. And when you see that, then you can cross multiply. Don't forget an equals sign between them. What I've noticed in the past is sometimes students put times between them and they end up multiplying it and getting a bigger answer there. They're not sure what to do because they can't solve. Or there's another way to solve this that works perfectly fine, and it's completely up to you which way you want to use it. So the other option is I have t over 9 equals 5 over 6, and I'm going to put or fraction buster, because you have fractions, right? And we can use this anytime we have a fraction and we have an equal sign, which we do. So remember, for your fraction buster, you're going to find your LCM. Hopefully most of you noticed that your LCM there is what? Hopefully you found it was 18. Remember, first thing each of these multiply to be. 6 times 3 is 18, 9 times 2 is 18. So because my LCM is 18, I'm going to multiply this side by 18, and I'm going to multiply this side of the equation by 18. Now I'm going to cross cancel, not cross multiply. 9 goes into 9 once, 9 goes into 18 twice, 6 goes into 6 once, 6 goes into 18 3 times. Notice these both canceled, which we wanted. And now we have 2 times t, which is 2t, equals 5 times 3, which is 15. You're solving for t, so you divide both sides by 2, and you get t equals 15 over 2, or 7.5. And notice it's the exact same answer. Answer should not change. Example 5 is a word problem, so we're going to go ahead and write the basics of the word problem down. A box of cereal, so I'm just going to say, actually we'll just put that. A box of cereal weighing 350 grams contains 21 grams of fat. Find the number of grams of fat in a 50-gram serving. So the key to setting up a proportion, and I know some of you might still need to write, so just hit pause. The key to setting up a proportion, main thing that you need to know for sure, is that they need to be across the line equal. And what I mean by that, across the equal sign, is let's just call this serving. So serving over, let's call the other one fat, equals serving over fat. Or fat over serving equals fat over serving. So notice here that across the equal sign, whatever I choose that's my serving size needs to either both be in the numerator or both be in the denominator. Whatever I choose to be my fat here needs to be either both in the denominator or both in the numerator. One thing is going to be a variable. One part of one fraction will be the variable. So every time here you're going to be given 3 pieces of information, one is going to be missing. So let's go ahead and use this one since it's there. So look up there, you know you're going to have 2 fractions here. Something is set equal to the other thing. If we're putting fat at the top, grams of fat, a box of cereal weighing 350 grams contains 21 grams of fat. So I know I have 21 grams of fat there. What is my 21 grams of fat in? It's in 350 grams of the serving, or the cereal. So that would go at the bottom. Then I notice here it says find the number of grams. of fat. So that tells me my variable. Number of grams of fat is my variable. I have to line it up with the other grams of fat in a 50-gram serving. And that's how you set those up. Now you're going to solve it exactly like we solved the last one. Completely up to you if you want to use a fraction buster. You can multiply both sides here by your LCM, which in this case actually looks really easy to me. I would almost use a fraction buster in this one. Or you can do the cross multiplication. I'm going to go ahead just to show you how quick the fraction buster can be and work it out with the fraction buster right here first. So we have 21 over 350 equals f over 50. And I notice that my LCM is 350 because I know 50 goes into 350. So this is going to be really easy because I noticed that. I multiply this by 350 and I multiply this by 350. That's a 1, and I bring down my 21. 50 goes into 50 once. 50 goes into 350 7 times. Now I have f times 7. Remember, your coefficient always goes in the front. So I have 7f. And now I divide both sides to solve for f. And I find out that 3 equals f, and then I'm going to answer my word problem. So there are 3 grams of fat in a 50-gram serving. Or a 50-gram serving has 3 grams of fat. Okay, now I'm going to show it to you cross-multiplying just so you get to practice both. Sometimes it really is better one way or the other just based on what the numbers are. So I have 21 over 350 equals f over 50. And when I go to cross-multiply, I'm going to have 350 times f, and it doesn't matter which one you want to go first with. It's just one will end up on one side of the equal sign, the other one will end up on the other side. So I end up with, I'm going to go ahead and write over here, 350 f equals 21 times 50 is 1050. And now I go to solve my equation, so I'm going to divide both sides by 350. And I already know just from doing this that it's 3. But you'd have to do long division there, or try a couple multiplications, or use a calculator if it was a homework assignment. And then I would go ahead and answer it the same exact way. There are 3 grams of fat in a 50-gram serving. The last example is example 6. Solve. This one's really important, and for some reason every year students really have a hard time with this one. So hopefully everyone sees it this year and gets practice at it and really thinks about it. This looks a little different than the other proportions, so take a look at it, try to figure out why it looks different. Hopefully you notice that you have 2 terms in your numerators on each side in this case. Sometimes you'll only have on one side. It doesn't matter. When you see 2 terms, you know automatically that you need to think of that as a term, as 2 terms, and that as 2 terms. And so those parentheses need to go around there, really important, because of a certain property you're going to have to use. So when you go to cross multiply, you need to be aware that there's 2 terms you're multiplying the 7 to. You're not just multiplying 7 to x, you're multiplying 7 to the quantity x plus 4. So you rewrite it 7 times the quantity x plus 4 with those parentheses equals, And then same thing when you go across here, because we had the binomials. These are called binomials. Nomial term, two terms. So bi is 2, nomial term, 2 terms. So now I'm multiplying 5 times the quantity x minus 2. And hopefully everyone noticed here that you should distribute. So you draw your line, and now you're going to distribute, and you end up with 7x plus 28 equals 5x minus 10. Don't forget to distribute. Now you move on to the next step, which is, okay, I need to get variables on the same side. Notice they're on opposite sides. Remember, when you're going across that line, you're using opposite. If they were both on this side, you would just combine them. So I need to use the opposite, the inverse operation. I went ahead and moved 5 because I know 5 is less than 7, and I like those positives when I can get them. So now I end up with 2x plus 28 equals a negative 10. Okay, my line out of my equal sign is still going. Now I'm going to get rid of, here's my variable that I'm solving for. So I'm going to get rid of 28 first, and the inverse operation would be to subtract 28. Be careful here. Don't miss problems like this over silly mistakes. I have 2x left over. I have 2 negatives. So I add them, keep them negative. Remember, the other way to look at it would be like that. I have a negative plus a negative, so it's a negative 38. Notice I didn't get away from having a negative there this time. It still showed up. And now I divide both sides by 2, and I have x equals a negative 19. And then again, you could go plug that in. Negative 19 plus 4 is a negative 15, and a negative 15 divided by 5 is a negative 3. So now I'm going to check it on this side. I want it to also be a negative 3. Negative 19 minus 2 more is a negative 21. Negative 21 divided by 7 is negative 3. So those balanced. They're equal. Alright, let's write a little bit on the left. This is called a multi-step proportion. And you have a binomial. And remember, if you don't remember what that is, it's something like x plus 2. And so you always want to put it in parentheses. And again, here we could have used a fraction buster. We could have multiplied both sides by 35. But if you were going to do that, you would need parentheses around that before you did it. You will need to distribute to any binomials. Or even more than that, let's say we had 3 terms up there, you would need to distribute to all of them. Okay, and then the rest you already know.